Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And in today's video tutorial we are going to be taking a look at the insertion sort sorting algorithm. Now in the previous couple of videos we've discussed selection sort sorting algorithms, so if you have missed that you can check out this entire DSA playlist. I'll drop the link in the video description. And with that being said, let's get started with today's topic. So we'll divide this insertion sort sorting algorithm in two parts, that is two videos. The first part, which is this one, will have the entire working, the theory and what happens behind the scenes. So we will dry run the algorithm as well. And in the next part, that is part 2, we will actually implement the insertion sort using C++ programming language. So if you're just interested in the programming part, just watch the second video, the part 2. But if you're not really sure about the algorithm, make sure you watch this video very well, because in this video we'll actually take what happens behind the scenes. We'll see the algorithm, we'll see the theory, and we'll also try to diagrammatically dry run the entire algorithm. Okay, so starting off with a little bit of theory. So insertion sort is a simple sorting algorithm, pretty much kind of like selection sort because the time complexity is the same. We'll come to that. And it works the way we sort playing cards in our hands. So when you have some cards in your hands, let's say you have playing poker cards in your hands and you want to sort them in ascending or descending order, you pick a particular card and insert it in the appropriate location so that it becomes sorted, right? So insertion sort pretty much works in that sense. And if you don't get it as of now, we'll understand the working as we move ahead. Just follow along. This is just a little bit of theory that we are going ahead with. Now insertion sort is a simple sorting algorithm that builds the final sorted array one item at a time. So again, pretty much similar to selection sort, wherein we were selecting one element and putting it in the start of the array in the sorted subarray. So we were selecting the smallest one. In insertion, we don't select the smallest one. That's the difference. Now this sorting algorithm is efficient for small data sets, much like other quadratic sorting algorithms. When I say quadratic, it's because the time complexity is to the power of 2. And it's more efficient in practice than most other simple quadratic equations, such as selection sort or bubble sort, just because the way it operates. The time complexity, as I mentioned, is O of n square. Now we've not discussed in detail about time and space complexities, the asymptotic notations so far in this playlist, but I will cover a separate video tutorial just for that. I'm trying to cover the sorting algorithms first and then we will have this topic of time and space complexity. So if you're watching this video in future, maybe that video will already be there in this playlist. If not, just subscribe and turn on the notifications, then you'll get notified whenever I upload that video. But yeah, this was a little bit of theory. If you are making notes, you can make a note of these points. Let's move ahead and see the working. So when it comes to the working of insertion sort, you have 5 simple steps if you put it in proper English. So step number 1 is pick the next element. You start from the left to right. Okay, you pick the next element. Step number 2 is you compare it with all the elements in the sorted sublist on the left. So you pick the next element and you compare it with all the elements to the left of that element, and to the left of that element will be a sorted sublist which will slowly build up. And if it is not making sense, you'll actually see when the working comes. So just hold on for a few minutes, you'll understand it very well. Shift all the elements in the sorted sublist that is greater than the value to be sorted. Now this is when you are sorting in ascending order. So you have to shift all the elements which are on the left of this element that you picked and which are greater than this element. Then step number 4 is insert the value that you picked at the particular location and you repeat it until the list is sorted. Now I would request you guys to just note down these steps, maybe take a screenshot or note it down, because I know it is still not making a very clear sense of these 5 steps. But once we see the working algorithm and once we try to dry run it, then it will be very clear. So let's move on to the algorithm now. Now that you've seen the 5 different steps in the working, if you see the algorithm and if you dry run it, which we are going to do now, you'll understand it very well. Okay, so let's see the algorithm. Okay, so this is the algorithm starting from the start point to the stop point. There are certain variables that we've created, and the array that we are going to use is an integer array, which you can see over here. It is having a size 5 and it has 5 integer elements 9, 7, 3, 6, 2. Okay, so this is that array and we are going to apply this insertion sort on this array. Okay, so this is the entire algorithm. We have step number 1, 2, then we have a loop which has some internal steps 2.1, 2.2. Then we have an inner loop at 2.3. We have 2 instructions inside the inner loop. Then we come outside that inner loop and then we have one more last instruction and we end the loop and we stop. Okay, so these are simple steps in this algorithm and if we try to read them as of now, it will not really make a lot of sense. But once we go step by step and try to apply these steps onto this array, things will slowly become very clear to you. So let's start off with understanding this algorithm. So we have A, which is array of items. This is that array ARR or A. Okay, it's one and the same thing. N is the size of the list, N is 5, so I have directly hard coded it over here. Then we have certain variables. So you can see step number 1 says declare variables I, key and j. So these are those 3 variables I, key and j. Now what we're going to do is we're going to dry run this algorithm. So when I say dry running it, we are going to go step by step throughout this algorithm, and we are going to see the values and track the values of all these 4 variables, specifically these 3 because the size N is going to be the same all the time. So we're going to track the values of I, key and j at every loop, every iteration, and then we'll see how this algorithm affects this array ARR and how the sorting progresses. Okay, so let's start with the algorithm. First thing, declare variables I, key and j. Initially, obviously, when you declare variables, the value would be 0. So let's write down 0 inside. Okay, so moving ahead, we have a loop of 1 to n minus 1. Okay, so this is step number 2. Here what we do is we assign this I equals to 1 to n minus 1. So the outer loop, we are going to use I value to iterate. So this is going to be I equals to 1 to n minus 1. So let me just quickly make that change over here. Okay, so we have I equals to 1 to n minus 1. So the loop is starting with I value as 1. So let's note the I value over here. I is 1 and I will run to n minus 1. What is n value? N is 5. So 5 minus 1 is 4, right? So I'll just write down 4 over here so that we refer it every time. So initially I value is 1, right? So you can see it from these values that we are tracking over here. I is 1. So you go inside the loop. Now inside the loop we have 2 instructions, 2.1 and 2.2. So at 2.1 what we are doing is we are saying key equals to A of I. Now we know I value is 1. Now if you see the array at the index position 1, we have the value of 7. So 7 will be transferred into key. So let's make that update and let's update this variable. So key is now 7. Okay, so what we did over here is we just picked the next element. Remember it was step number 1 or 2 in the working. At step number 2.2, we say j equals to I minus 1. What is the value of I? I value is 1. So we say 1 minus 1 equals to 0. So j is storing 0. Okay. So far so good. Let's move on to step number 2.3. At step number 2.3, we are having an inner loop, right? Which is a loop inside this loop. So here we are saying j equals to or greater than 0 and ARR of j is greater than the key. So this loop will run only when these two conditions are true. So the first condition is j should be greater than or equal to 0. What is the value of j? It is 0. So this condition is true, right? Because j should be greater than or equal to 0. Now j is equal to 0. So this loop will run, right? But then we have the second condition also. But here we are saying ARR of j should be greater than the key. What is j value? J value is 0. What is the value at 0 index? It is 9, right? You can see. Now 9 is greater than the key value. What is the value inside key? You can see 7, right? So 9 is greater than 7. Even this condition is true. So now we go inside the inner loop. Now inside the inner loop what we're doing is we are saying ARR of j plus 1 equals to ARR of j. Currently the value of j is 0. So ARR of 0 plus 1 is ARR of 1. That is array of 1 equals to ARR of j. What is ARR of j? Which is ARR of 0. So whatever is inside ARR of 0, which is 9, is being transferred into ARR of 1. So this 9 is being transferred in ARR of 1. So at this position, right? So what we did over here is we copied this value inside this value. So this now becomes 9, okay, at this step. So essentially what we're doing is we are shifting this element 9 at this position because 7 is smaller than 9, right? So if you are sorting this in ascending order, 7 should be over here and 9 should be over here, correct? So this is that process happening. So first we have to shift and make space for this 7. And if you are wondering where the value 7 is, the 7 value is still stored in our key variable, right? So first we actually shift these values, and right now we only have to shift one value because we are starting from the left to right. So we shift 9 at position 1, index position 1. So we get 9 over here. Then at step number this 2.3.2, we say j equals to j minus 1. Now essentially j is 0. So 0 minus 1 will give us minus 1. So let's update that. We have minus 1. Now this is the end of the loop, so we will come back at the start of the loop and now we will check the conditions. Is j greater than equal to 0? This time it is not greater than equal to 0 because it is minus 1, right? So now we will exit the loop. So we will come from this inner loop to this last step 2.4, and here we are saying ARR of j plus 1 equals to key. Now what is the value of j? Minus 1. So when you say minus 1 plus 1, we get ARR of 0. So at ARR of 0, we are storing the key value. Now remember, the key value is 7. So 7 is stored at ARR of 0. So this will be 7 over here. So I hope you're understanding what is happening. We just swapped 9 and 7. And if you actually see on the right hand side, let's see the values. After this algorithm runs for the first time, so after 2.4, obviously we are going to come at the end of the loop, and this loop is the outer loop. So this is that loop. So we will again go back to the start, right? Let me use another color. So here is the end loop and we will go back to the start after the first iteration. Now I will become 2, right? So I was 1 for the first time. So I now will become 2. So let's change it. Let's do 2 over here. And then again these steps will be carried out. So before carrying it out, let's see what happens in the diagram. So after step number 1, that is after this algorithm runs for one time, this outer loop runs one time completely, we take 7 and insert it in position 0. So this is what happened over here, right? So 7 came over here, 9 is here, and all the other elements are still as it is, 3, 6, 2. Okay. So from the left hand side, you can see that we have the sorted subarray which is getting built up, and on the right hand side, we have the unsorted subarray. So what we are essentially doing is, at every iteration, we are picking up the next element, comparing it with all the elements on the left, and depending upon which is greater and which is smaller, we are placing it, that is, we are inserting that picked up element at its particular position. Okay, so let's do this iteration one more time and let's rerun this and move on to step number 2. Okay, so after the first iteration, this is the result that we've arrived at. Now we come back to the start of the loop, right? So now the I value has become 2. So this is what I've updated over here. So coming inside the loop, we have 2.1. We say key is equal to A of I. I is 2. So array index ARR of 2 is 3. So now the key value is storing 3. Let's update that. Let's use yellow color itself. So key value is 3. Okay. We store it inside the key. Then we move ahead at 2.2. We say j equals to I minus 1. What is the value of I over here? 2. Right? The updated I value is 2. So we say 2 minus 1, which is equal to 1. So now j becomes 1 over here. Okay. Now we come over here at 2.3. We say loop j should be greater than or equal to 0 and ARR of j should be greater than the key. Now we know that j value is 1. So 1 is greater than 0. So this is true. But this condition also should be true. Now ARR of j. What is ARR of 1? You have to see the updated array. ARR of 1 is 9. Right? So we say is 9 greater than key. What is the key value? 3. Right? The value stored inside key is 3. Is 9 greater than 3? Yes, it is true. So now we go inside this loop. Here we say ARR of j plus 1 equals to ARR of j. So j value is 1. So 1 plus 1 is 2. So ARR of 2 is equal to ARR of 1. Right? So let's see in the updated value what are the things that are changing. What is ARR of 1? 9. Right? What is ARR of 2? 3. So 9 is being transferred at this position. So 9 is being shifted at ARR of 2 location, right? So if you can change this and make it 9, okay? Then we move ahead, we say j is equal to j minus 1. What is the value of j? J is 1. You can see, keep a track of the variable values over here. So j is 1. So 1 minus 1 is going to be 0, right? So the new value of j becomes 0. Let's update it. Okay, so now we come at the end of the inner loop. So we again go to the start to check all the conditions. Now the condition is again j should be greater than or equal to 0. The current value of j is 0. So 0 is equal to 0. So again this condition becomes true. Let's check the other condition. ARR of j, that is ARR of 0, should be greater than the key. What is the key value? 3. What is ARR of 0 from the updated list? 7. Is 7 greater than 3? Yes. So even this condition is true. So we again go inside this loop. So the inner loop this time is executed 2 times. So we come at step number 2.3.1, ARR of j plus 1, that is ARR of 1 because j value is 0, right? So ARR of 1 equals to ARR of j. So ARR of 0. So if you see the value at ARR of 0, it is 7. So 7 is now being transferred at ARR of 1. So this 7 is transferred over here. So you can see the shifting is happening. So now if I erase these two things, so we'll have 7 here also, but we are just copying this 7 over here. So you can see 7 and 9 got shifted and there was a 3 over here. So that 3 will actually come at this location. So that will happen after this inner loop exits. So we are at step number 2.3.1. We go ahead, step number 2.3.2. Now we say j is equal to j minus 1. So j becomes minus 1 now, right? Because j was 0. 0 minus 1 becomes minus 1. So let's update that. So we come at the start of the loop after we reach the end of this inner loop. Now the condition becomes false because j is minus 1. So we exit outside this loop at the last step 2.4. Now we say ARR of j plus 1 equals to key. What is j right now? Minus 1. So minus 1 plus 1 would be ARR of 0. What is the value of key? 3. So we store 3 at this ARR of 0. So at this step ARR of 0 we replace it by 3. So what we did is we picked 3, we stored it in a key variable, then we compared it with the two variables or two elements which were there on the left of that. So 3 was over here, you compared it with 7 and 9, right? And we found out that 3 is the smallest, so technically 3 is supposed to be coming before 7 and 9. So we first shifted 7 and 9 1 places ahead and we made space for 3 and then we transferred 3 over here. So after step number 2, that is the second outer iteration. So after 2.4, obviously we end the outer loop and we again come to the start of the outer loop. Now I value becomes 3, right? So let's change it to 3. Let's use some other color now. We'll use the red color now. So I becomes 3. So 3 is still less than 4. So we have to run from 1 to 4, right? So after second iteration, after the second time the outer loop executes, let's see what changes happen. So we have to take 3 and insert it at position 0. So you can see we inserted 3 over here and we shifted 7 and 9 to the right. So we have 3 and 7 and then we have 9, 6 and 2. So slowly the sorted subarray is increasing in size. So these two are sorted, 3 and 7 in proper order, but 9, 6 and 2 are still unsorted, right? So this is how the insertion sort algorithm progresses. Now let's run this algorithm for one last time. Let's continue this. We are on I equals to 3. So we are on step number 3. Let me just erase everything out first. Okay, so we have I equals to 3, right? Now we say key equals to A of I. So we have to observe this. So I is 3. So A of 3 is 6. So 6 is being stored in the key value. So let's update the key. We have 6 over here. Okay. Moving on to step number 2.2. We say j equals to I minus 1. The I value is 3. 3 minus 1 is 2. So j becomes 2 over here. Coming in on 2.3. I'm moving a little faster because by now you should get the hang of it. We are coming at the inner loop at 2.3. J equals to or greater than 0. J is 2. So this condition is true. ARR of j should be greater than the key. What is ARR of j? Now j is 2. So ARR of 2, if you observe, is 9. Is 9 greater than the key? What is the key value? 6. Yes. So we go inside. We say 2.3.1. So here we are saying ARR of j plus 1. J is 2. So we are saying ARR of 3. So at position of ARR of 3, we are storing ARR of 2. Now ARR of 2 is 9. We are shifting 9 over here at position number 3. So let's erase this 6 and write 9 over here. Then we come at 2.3.2. We say j equals to j minus 1. So now j becomes 1. Okay. We end the loop. We again come to the start of the loop. Now we check, is j greater than 0? Yes. J is 1. It is still greater than or equal to 0. Now we check the next condition over here. Is ARR of j, that is ARR of 1. What is ARR of 1? 7. Is 7 greater than the key? What is the key? 6. It is again true. So now we again go inside the loop at step number 2.3.1. This time we say ARR of j plus 1. j is 1 over here, so ARR of 2 should store the value of ARR of j. Now ARR of j means ARR of 1. Now ARR of 1 is 7 if you observe over here. So 7 is being transferred at ARR of 2. So now 7 we transfer at this index position. So we erase this 9. We write 7 over here. Okay, so you can see 7 and 9 got shifted one position ahead because we have to make the space for this key value 6, because 6 is smaller than 7 and 9, right? So we come at the end of the loop now. Before coming at the end of the loop, we say j equals to j minus 1. J was 1. So now j becomes 0. Okay. So again we come at the start of the loop. Again we check the condition for j greater than or equal to 0. Now j is 0. So 0 is equal to 0. Right. So this condition is true. But if you see the second condition now, the second condition is ARR of j, that is ARR of 0. So ARR of 0 you can see is 3. So is 3 greater than the key? The key value over here is 6, you can see. Is 3 greater than 6? No. So now this loop condition is become false. So we don't go inside this loop this time. So we directly end the loop and we come outside the loop to step number 2.4. Now why did this become false is because we don't want 6 to come before 3, right? 3 is smaller than 6, but 6 is smaller than 7 and 9. So technically 6 position should be over here, right? So that's why now we say ARR of j plus 1 equals to key. So that's why we did not reduce the value of j. What is the value of j? 0. So at this step j plus 1, we are saying 0 plus 1. So at position ARR of 1, we are storing this key value. So at this position, we are storing the key value which is 6. So now 6 will come over here. So you can see that now we have 3, 6, 7. So we have these 3 in proper order. So after step number 3, that is after the outer loop executes 3 times. So we are at the end, we again come back to the top. Now I will become 4. So this is the last iteration. So after that, we will have 3, 6, 7 in the sorted subarray, and we will have 9 and 2 in the unsorted subarray. So now we are at the last iteration because I value has now become 4 and we are going to execute it one last time. So what I'll do is I'll give this step for you guys. What you can do is you can take a pen and paper and try to dry run it yourself. Ultimately what will happen is this 2 will come over here and again 3, 6, 7, 9 will be shifted one positions ahead. Okay. So the end result will look something like 2, 3, 6, 7, 9. You can see at step number 4, that is the last step, we take 2 and insert it at position 0. And rest of the elements will be shifted one place ahead to the right. So just go ahead and dry run it. I'm pretty sure you'll get the hang of it. And I hope you've understood the entire algorithm and how insertion sort algorithm works. If you have to make a difference between selection sort and insertion sort, in selection sort what was happening is we were selecting the smallest element in the entire array and we were bringing it to the sorted subarray, and then we were moving ahead one place in the sorted subarray. But in insertion sort what we do is we don't select the smallest element, we select the next element and we compare it to the other elements which are there on the left of that element, and we insert that element in its appropriate position. And this insertion sort is pretty much similar to how we sort the playing cards, and that's why it is having a lot of similarities with that. So yeah, that's it for this video guys. I hope you understood the insertion sort sorting algorithm. We saw the theory, we saw the 5 different working steps, and ultimately we also saw the algorithm. In fact, we dry run that algorithm step by step to see how it progresses and how the values change in the array. So that's it for this video guys. If you like this video, please give it a thumbs up. Let me know in the comments how this video was. Do share it with your friends as well, and I'll see you guys in the next video where we will implement this insertion sort using C++ programming and convert this algorithm into C++ code. So thanks for watching. See you in the next one. Peace.